Okay, so we're gonna do 6.1 today, power series. Okay, so power series, basically series with the power, but let me write down power series is infinite polynomial in series. And then later on, chapter sections, we're gonna define new functions as a power series. So, okay. All right, then the power series looks like this. Summation n start to 0 to infinity. C sub n x to the n power. Okay, you can see that there is a power. All right, then when n equal to 0, then c sub 0, right? C is the constant. And plus when n equal to 1, we have c sub 1 x to the first power, plus when n equal to 2, we get c sub 2 x to the second power, and so on, right? And keep on continue until infinity. We call this as a power series. This is the form of. Okay, if we don't have the constant, so C7. X is variable, right? We know that. Okay, we have the form of a power series like this too. X of n, when n starts to 0 to infinity, when n equal to 0, we get 1, right? When n equal to 2, I'm sorry, when n equal to 0, we get 1. When n equal to 1, we get x. When n equal to 2, we get x squared, and so on, right? All right, we talk about this later on. Now, I want to write down the definition of power series. So we just said that the form of series like that, C sub n x to the n power C naught plus C sub 1x plus C sub 2x to the second power. Keep going. We called this is a power series centered at x equal to 0. Okay, now if we have this form, C sub n x minus a to the n power. So let's do it. When n equal to 0, we have C naught and 1, right? When n equal to 1, C sub 1, x minus a, right? When n equal to 2, we have a C sub 2, x minus a to the second power, and so on, right? Okay, this one we said that is a power series centered at x equal to a. Okay, now there's an example of power series. Okay, when center at x equal to 0, oh, So we have this kind of power series, x to the n over n factorial. Okay, when n equal to 0, we have 0 factorial, which is the 1, right? So it's a 1 for the first term. When n equal to 1 and x to the first power, 1 factorial, which is the 1, right? When n equal to 2, we get x to the second power over 2 factorial, which is 2. We did that yesterday, right? Good. It's like that, right? If we want to make a factorial form, that's fine too.
So, just scroll out.
Scroll down.
Scroll up for a second.
Okay, up, down.
Okay, thank you. Good. Yeah, thank you. Okay. I'm good. I just needed one number.
All right, so this is also centered at x equal to 0. So we have a series from n equal to 0 to infinity, n factorial x to the n, okay? So can you see that? X by itself, right? So we call the x equal, centered at x equal to 0. All right. So when n equal to 0, 0 factor is the 1, then we get the 1. When n equal to 1, 1 factor is the 1, so we get x, right? And then we get 2, then 2 factorial, x to the second power, 3 factorial, and x to the third power, and so on, okay? Now, when centered at x equal to a, okay? So in this case, it's a 2. Let me show you what's the 2. So series, when x equal to 0 to infinity, we have x minus 2 to the n power and n plus 1, 3 to the n power. Can you see that here? So centered at x equal to 2, all right? Okay. Equal to 1 for the n equal to 0 plus when n equal to 1, so we have x minus 2 over 1, so we get 2 there and 3 to the n. Oh, I'm sorry, 1. And n equal to 2, x minus 2 squared and 2, so 3 there and 3 squared, right? And so on. Okay. All right. Now we want to talk about the convergence of a power series. So let me bring the screenshot here. Which one? This one. Okay, so this is the one, convergence of a power series. So this one, we have centered at when x equal to 8, right? All right. Now they say that the convergence of a power series, then look, the series converges at x equal to a and diverge for all x cannot be equal to a, okay? There's one condition. Now, series converges for everywhere the real numbers, okay? So let me write down for you. Means converges only one point. means converges everywhere. Now, they say that there exists, I'm doing the third one, there exists a real number R. They indicate R in this section, the radius of convergence. Okay, so okay, then let me see. We have the series converges with absolute value x minus a less than r, which is radius of convergence, if the absolute value x minus a greater than the r, which is radius convergence, then we say the diverges. Okay. Then the absolute value is the same as the radius convergence, then the series may converges or diverges. Okay. All right. The first time is hard to understand, so let us do more. Let me write down the interval of convergence. So let me write down here. The set of values x for the series. Okay, so I am writing down the power series converges is known as the interval of convergence. Okay, so from the algebra or pre-calculus, whatever the previous courses, right? Interval, we have a parenthesis or bracket or parenthesis bracket, bracket parenthesis. That is the interval in the number line, right? On the number line, right? So same as here too. So interval. So we take the, if there is convergence, right? What's the interval of convergence, all right? So how much they include there as a convergence, all right? Okay, now we talked radius of convergence, okay? So radius of interval is the R. So let's say that. Since they say that, look, let me just write the R is the radius. Nothing special, they just using the first letter as R, okay? All right, so the radius of convergence, it depends on the convergence, all right? So we do more. Here, we have another definition. Let me bring here. So I'm gonna give you a little time to write it out. Okay, let me bring the screen shot. This one. Okay, so there is a lot of wordy. So it's better we understand with the picture. That's why I brought the picture here as well. Okay, this is the definition about the convergence, converges, and the radius of converges. Take a look. All right, so we have a series. Then I just said that set of all real numbers x. Okay, then where series converges is the interval of convergence. Okay, if there is a convergence, we set the real numbers and we include which part is converging. Okay, that is the interval. It can be parenthesis, 2 parentheses, it can be 1 parenthesis bracket, or it can be 2 brackets, or parenthesis here, bracket there. All right, means that we include the endpoint or not, right? Parenthesis means not include the point, we bracket then include the endpoint, right? All right, then they say that the absolute value is less than the radius converges. Then diverge for the absolute value x minus a is greater than r. Okay. Then r is the radius of convergence. Okay. Okay, if there is only one point, x equal to a, then the radius converges is r equal to 0. So here, that picture is here, only one point when x equal to a. So only converges only one point. In this case, x equal to a, okay? Then we say that the radius converges, okay, r means radius converges. Convergence, the noun, equal to 0, okay? Let me explain to you why just 0 there later on. Okay, then second picture said that look, converges on the number line everywhere, right? So this means converges everywhere. Then they give us the r, which is infinity. So this means radius convergence, right? R means if we denote this one as interval notation, then we can say that negative infinity to positive infinity, right? That's the interval of convergence. Something interval of convergence. Okay, since there is no space, let me write it down the left side. Look, I'm looking at the C picture. Converges only middle part. Okay, then we have, since this is only the converge part. Oops. Converges. Converges. Only one point, converges everywhere. Converges only those interval, right? Can you see that part? Okay, so if we have a in the middle, okay, so right side we said a plus r, which means if we have centered at a, then we say that a there, and r, which is a radius of convergence. Okay, convergence. And the left side is a minus r. Okay, so in this case, interval of convergence. Okay, so interval of convergence, then the radius of convergence, if we want to know about the radius, right? Then it depends on the number, it changes that, right? But then in general, we get the formula like this, a plus r and a minus r like this, okay? So let us do examples so we understand everything this one, all right? Okay, once again, only converges only one point, then we say the radius converges, which is r equal to 0, converges everywhere, then r equal to infinity. Then interval of convergence, then we are using this formula, okay? All right, so let us do example. Okay, let me move on. Find the interval and radius of convergence. Okay, so when we find the radius of convergence, we always use ratio test. Okay, and let me bring the ratio test here. Definition. This is from the last lecture. Cut. I want to make it smaller because we went over already last time. So. Okay, so. Hey. How about here? So that I can make a little bit bigger, right? Okay. All right, so then we're gonna use ratio test. Ratio test said that we're gonna set it up the limit when n approach to positive infinity. Then we create a sub n plus 1 over a sub n in the absolute value, right? Then we called this is a rule in Greek. Now this rule is between 0 and 1, inclusive 0. And we say that the series converges absolutely, right? If rho is greater than 1 or equal to infinity, then the series is diverges, right? And exactly 1, then does not give us anything, right? Okay, let us do this. We have. So I'm gonna do 3 times everything, okay? So we have a series when n equal to 0 to infinity, we have x to the n power over n factorial, okay? Now, so we have a rule equal to limit when n approach to positive infinity, have a absolute value, a sub n plus 1 over a sub n, right? So we had the experience yesterday, so we're gonna just substitute n plus into n, right? So we have limit when n approach to positive infinity, x to the n plus 1 over n plus 1 factorial and times the reciprocal of the second one. So we're going to just rewrite with the reciprocal of the original series, right? Okay. Now we can simplify, right? So we know that there is n, right? And then we know that there is 1, so we can simplify this way, right? And n factorial with n factorial. All right. Then we get limit when n approaches to positive infinity. What's the remain? We get x over n plus 1, right? Okay. We have to deal with x and n, all right? Look, when n approaches to positive infinity, right? And you see here, so let's take out the x out. All right. Or we can just take out the absolute value. That's fine too. All right. So what is this? When n approaches to positive infinity, 1 over n plus 1.
0.
0. Very good. So we get, okay. Now we have to think, right? So we want to make a convergence easily. This one, look. Less than 1 is convergence, isn't it? Row less than 1. Yeah, it's converges by ratio test. Okay, then we have to say about the x. Look, we have a 0 there, right? Any number we multiply with a 0 is 0. Make sense? So we can say about the x, for all values of x there, okay? So let me write down. For all values of x, the series converges for all real numbers. Because think any number times 0 is 0. Okay, which is less than 1. Okay. All right, then we say that converges everywhere, right? So this will be means converges everywhere. Because we talk about the x, yeah? Okay, so for all x values, converges everywhere, right? That means interval, let me write down. So everywhere on the number line, right? So converges. Then we can say the interval of convergence is negative infinity to positive infinity, and then the radius of convergence, which is infinity, right? Radius of convergence is, so we make R equal to infinity. All right. So this case is number 2. All right. So this is the number 2 case. This one converges everywhere. Okay. So converges everywhere. Radius convergence, which is R equal to infinity. And interval of convergence. So we get the negative infinity to positive infinity. Make sense? All right. Second question we got. Summation n equal to 0 to infinity n factorial x to the n. All right, so look, rho equal to, take the limit, n approach to positive infinity, a sub n plus 1, a sub n equal to. All right, so we're gonna make a sub n into the n. So look, we will have n plus 1 factorial x to the n plus 1 factorial over, oh, they don't have fraction, right? Now we're gonna make a sub n, so n factorial x to the n factorial, right? All right, so in this case, we don't want the undefined, so x cannot be equal to 0. Can you see that? Don't want it. Undefined. Yeah. Okay. Now, let us simplify. So we get n, so we have n there, n factorial with the n factorial, and then x to the n power with x to the n, so we get the 1 there, okay? Now, we have a limit when n approach to positive infinity. Let's see, we have n plus 1 remain and x remain there, okay? Now we take out the x out from the limit. So we have x and limit when n approach to positive infinity, we have n plus 1, right? Okay. So what is this?
Infinity.
Yeah, it goes to infinity, right? So we say that this is infinity. Then by ratio test is diverges, right? Okay, now we have to understand. It's a little bit tricky. Look, we say that x cannot be equal to 0 in this case because we don't want the undefined, right? When x equal to 0, right? So we set it up in the beginning, x cannot be equal to 0. But in this case, diverge everywhere. But then in that case, it's type number 1. Can you see that here? Type number 1 diverges everywhere, right? Except to 1 point. Can you see that? So in this case, converges only one point. Very good, okay? So we say that this means, listen, this means diverges everywhere, right? But then we restrict only one point, x cannot be equal to 0 in the first place, right? So only the point is converges, all right? So let me write down here the series diverges for all x, but except x equal to 0, okay? All right. So we can say that by type 1, so think about a picture in your brain. So at the point, let me write down just here. When x equal to 0, it converges. Different color. Convergence at this point, okay? Then diverges everywhere, okay? All right, then we said that interval of convergence, only one point. So let me write down. Of convergence. There is no interval, only one point, right? So we can say that x equal to 0. Then radius convergence, radius of convergence is what they say? Or equal to 0, okay? Because there is no length of radius, okay? So radius convergence, I probably say better. Radius convergence, where it go? Maybe radius convergence, think. Think the length of interval. Okay. But then, the type 3 has a little bit different. Okay, just remember that like that, because the all type has different radius convergence. That's why it's hard to say in one definition. I said I think. Okay. You will see why is every type is different of radius convergence. Okay, so in this case, we have only one point of convergence. So radius of convergence is 0, okay? Only one point, that's why it's 0. In this case, radius convergence is, look, everywhere. That's why we say the infinity, right? Okay, so we did it 2 times. Now one type left, interval of convergence, okay? So let us do this one. Number 3.
What was the radius of convergence for this last one we did?
Oh, sorry. Radius of convergence is r equal to 0, right? Because only one point. Okay?
Thanks.
All right. Okay, so number 3, we have a series x minus 2 to the n power over n plus 1, 3 to the n. Okay, so can you see that centered at x equal to 2? This one? Okay, now we're gonna do ratio test roll. Limit and approach it to positive infinity. So we're gonna substitute n plus 1 into the n. So we will have a sub n plus 1. So x plus 2 to the n plus 1 over, look, n plus 1 into the n plus 1, 3 to the n plus 1 there, right? Okay, now reciprocal of a second fraction. So we're gonna just, second fraction, which is n plus 1, 3 to the n there over x minus 2 to the n power, okay? All right. Okay, let us do this. Simplify. Oh, really? Sorry, thank you. Ooh, good to know, right? Minus 2. It's minus 2, right? X minus 2. All right, so we have x minus 2 to the n power, then we have a 1 there. X minus 2 to the n power, good. Now, we have a 3 to the n power and 3 to the n, so we have a 1 there, right? 3 to the n. I mean, the 3 to the first power. So let's arrange a little bit. Okay, so we have n plus 1 over n plus 2 and 3, isn't it? Oh, then x minus 2 there. Oh, almost forgot, right? So x minus 2. Yeah, okay. All right, then. What about, yeah, we have a 3 there, right? Okay, then look, I can arrange.
Didn't cancel out the 3?
3. So we have a 3 to the n, 3 to the n, but
Oh, there's
3
one left behind, one left. Okay, yeah, okay.
yeah, right? Okay, I'm not, I don't make a mistake, right? So there's a 3.
Yeah.
Okay, good. All right, then we will see that. Let's take out the number with the x. So x minus 2 over 3 with the absolute value. Okay, now take the limit. When n approaches to positive infinity, we have n plus 1 over n plus 2. Now we can get it, right? What do you get this one?
Is it just the limit? Like, is it just 1?
It's a 1, right? So we have a 1 there. Okay, since the 3 is positive, let's do that over 3. Okay, now it's a 1, but it's easier to make converges, right? So we get the over less than 1 is converges by ratio test. Now we're gonna work the left side from the inequality. So we get this. So we have now. So we have x minus 2 over 3 less than 1 because times 1 doesn't do anything, right? Now we're gonna start for x. Then the little algebra works, so we make it times 3. So we have x minus 2 less than 3, right? Okay. Then from the algebra course, we have an absolute value is less than 3. Then we make this way. Negative 3, x minus 2, none. So x minus 2 is between negative 3 and positive 3. Inside for x, so we get positive 2 both sides. So we get positive 2. So negative 1, positive 2, 5, right? Okay, then look. We say that this is from 1, less than 1. This is how we solve for the x. Then this will be converges, right? Make sense? Okay, then we're gonna say that we're gonna find the interval, yeah? Same as, right? So we have a negative 1 and then we have a 5, right? X is between there, only that part is the converges. Convergence. Okay. So for now, we're not sure, so we make a parenthesis, okay? Convergence. Okay, then we say that the rest is a divergence, right? Okay, let me show you the type 3, right? So type 3 say that. Can you see that? Here, if we have an interval converges here, then the rest will be diverges. Okay, and then look, if we have A is here, then A plus R, A minus R will be the radius of convergence. Okay, hold on 1 second. Let me do this one first. Oh. Before we do that, should I conclude now? All right, so let me do this one first, and then I'm gonna show you the part of divergence, okay? So here, we say that centered at x equal to 2, right? So that means it's here, we have the series centered, so which is power series, right? Centered at x equal to 2, okay? That means centered at 2, okay? All right, then they say that by the type 3, they have, this is A, right? And then right side, which is A plus R, and left side, which is A minus R, right? For the X. Okay. We know that convergence between the interval is -1 and 5, but still we can check that, right? So let's check the radius of convergence. So let's see. We have x equal to x equal to a plus r. So right side, which is 5. A is the 2 plus r. Then r equal to what?
3.
3. We can check left side too. X equal to a minus r. So x equal to -1 equal to a was the 2 minus r. So r equal to what?
Also 3.
It's also 3. Okay. And then when we see the interval, right? We can see that from the 2, there is the radius of convergence. Can you see that here? Which is 3 units there. Can you see that? And then
Yeah.
can you see that also radius converging left side also 3 there? Yes? Okay, very good. That's why it's hard to say one definition, I say that one thinking, because there's a different types, okay? So in this case, radius convergence is, which is r equal to 3. We can conclude, okay? And interval of convergence is between -1 and 5, right? Okay, we're not done yet. There is stuff. So far, radius of convergence and the interval of convergence, right? Okay, now, interval, I said earlier. From the previous course, interval, we have like that. We have, since we have 2 parentheses, we have like this. We have like that, right? We have like this, right? This interval notation, right? Then this one is telling us, bracket is telling us we include the endpoint, right? The parentheses are telling us we not include the endpoint, right? No include. How about exclude? More sure, exclude the endpoint. Bracket, include the endpoint. Okay, all right. Then we found interval of convergence, okay? This is time number 3. Only time number 3 we can check that. Time number 2, interval of convergence, which is everywhere. So -infinity to +infinity. We don't know which number is the end. So we really cannot check bracket part, right? Time number 1, we have only one point is the convergence. So r equal to 0. There's no interval at all, right? All right. So time number 3, we have to check whether we are using bracket or parentheses, all right? So we're gonna make stays 2 parentheses or number 2 type or number 3 type, number 4 type, okay? That is the final answer for interval of convergence for type number 3, okay? All right, so let us do this. All right, so when when x equal to -1, okay, so check the, how about different color? Check the endpoint, -1 and 5, okay. All right, so this means when x equal to 1 -1, sorry. Then how do? We just substitute when x equal to -1 into the series, okay? Then we check whether still converges or diverges. If it still converges, look, we said that this is the interval of convergence, okay? We are using a bunch of other tests or series to find out converge or diverges, okay? And if this is a converge, yes, we can make a bracket. This is a parenthesis, I mean, this is a parenthesis. This is a diverge, then yes, we just keep the parentheses, all right? Okay, let's do this one. All right, so we have, when x equal to -1, the series, original series, when you copy nicely, oh, come on. Oh, come on, come on, come on, come on. Hey. Let me just write. So we have a series. 0 to infinity, x minus 2 to the n power over n plus 1, 3 to the n. Okay? All right. There. Okay? So we will have series n equal to 0 to infinity. We have a -1 and minus 2 to the n power over n plus 1, 3 to the n power. Okay? Now, the series n equal to 0 to positive infinity. We have a -3 to the n over n plus 1, 3 to the n. Okay? Yes. Thank you for letting me know. Then look, -3 to the n power, I can rewrite this way. So -1 n power and 3, right? And n power, right? I'm sorry, -1 times. -1 times 3 to the, right? Okay, now over, we have n plus 1 to the 3 to the n power, right? So we can simplify. Then what we have -1 to the n over n plus 1. Okay, what kind of test we have to use in this case? Someone said that last time, really good.
Is it an alternating series test?
Very good. So we're gonna check the alternating series test, okay? Okay, then we're gonna show, so b sub n plus 1 less than or equal to b sub n, okay? And we're gonna show the limit n approach to positive infinity, b sub n equal to 0. Okay, so first of all, we said that b sub n plus 1. So nothing special, we just plug in. Substitute n plus into then n, right? So we will have 1 over n plus 1, right? Which is 1 over n plus 2 less than or equal to 1 over n plus 1 equal to b sub n, right? That's true, right? Because the denominator is less in the b sub n, right? Good. Now we're gonna show that limit when n approach to positive infinity, b sub n equal to 0. So limit n approach to positive infinity. What can you say, this one?
0.
0, excellent. So yeah, there we go. It's the convergence, right? So only alternating series test tell us convergence, right? Okay, so thus the series converges. And alternating series test, right? Look, we substitute when x equal to -1, and we show that the part is the convergence, right? So this is a convergence, right? So we make a bracket there. Okay. All right. The other side, when x equal to +5, when x equal to, okay, series, let me copy. And then x -2 to the n power over n plus 1, 3 to the n power. All right, so we plug in there. So we will have infinity 5 minus 2 to the n power over n plus 1, 3 to the n. All right, so we get this 3 to the n over n plus 1, 3 to the n power, right? Okay, so we can simplify. So we have 1 over n plus 1. So how can you determine this one?
0.
With the the harmonic series.
Yeah, it's a divergent
Oh, yeah.
harmonic series. Yeah, divergent by harmonic series. Very good. So by the way, we did not take the limits. Okay, so we cannot say the 0, right? All right. Then divergence, so we don't include the number 5 there, right? So x equal to 5 divergence. Therefore, we can say that the final interval of convergence is bracket means we include the number -1. We don't include 5 as a convergence of interval, okay? And or equal to 3, right? The radius of convergence. So you guys okay? So we did all 3 different types. So let us do one quick example, all right? So totally different one.
I have a question. So why
Yes,
for this interval, why does the -1 get a bracket and then the other one just
okay, because we said that between -1, -5 is the convergence of interval, right? Yes,
yeah, okay.
but we're not sure about we include this point or not. Make sense?
Okay. So that's why we're doing this.
Yeah, so
okay,
-1
okay.
was the convergence. That's why we include the point in the interval of convergence. +5 was divergence, so we don't include the point.
Okay. That's the reason we did all this. Okay.
That's correct. Yes. It's not the only the interval of convergence we give to P.
So if it's convergence, we
Okay.
include it. If it's divergence, we don't include it.
That's correct. Because they say that it's
Okay.
there is interval of convergence. Yeah. Okay. Yeah. All right. So we did everything about the power series, interval of convergence, and radius of convergence. Okay. It's a different topic right now. So we have a power series. So this topic is about, they say that representing functions with power series. Okay, so maybe 10 more minutes. Okay, so power series. So we know that basic form is 1 plus x squared plus x to the third plus that. Okay, when center x equal to 0, so this one we express as a series form, which is summation form, I meant. So summation n equal to 0 to infinity x to the n power, right? Okay. Now this one very similar with the geometric series form. Okay. So geometric series form has the ratio, which is number, right? Look, let me denote this way, geometric series. Okay. So this is a plus ar plus ar squared plus ar to the third power, right? Okay, then this will be summation n equal to 0 to infinity a to the r to the n power, right? Okay, now by geometry series, absolute value of r is less than 1. We said it converges. Then what's the sum goes, right? If it converges, then they must converge to a number, right? Then they say that the sum is a over 1 minus r, right? If they converges, right? Then look, we can say that in this case, a equal to 1. Compare with this one. Can you see that? And since a equal to 1, r equal to x. All right, then look, I want to write down this format, okay? So this will be, we can say that a, which is 1 over 1 minus r, which is x. Can you see that? Okay. Then we can say that one more, right? Since they say that absolute value of r is less than 1 converges, right? So we can say that absolute value of x is less than 1 converges as well, okay? So everything is we follow the same format as geometric series here. All right. Okay, then let us do this one. The last one is the process. Present. Represent of the following. The following functions. Find the interval of convergence. Okay, so look, we have f over x equal to 1 over 1 plus x to the third power. Okay, so I just explained to you earlier that is 1 minus, this one, 1 minus that, 1 over x. Okay, look. Let me explain to you one more things before that. So we have, in this case, we have absolute value is less than 1, then we take out the absolute value is between -1 and 1. It's converges, right? Then it's okay. Now, look, we have the same format, but in this case, x cubed. So look, this one. This one I want to make 1 over 1 minus x cubed. Yeah. Because we have the same form, okay? 1 minus 1 minus x. 1 over 1 minus x. Yeah, okay. Look, then we follow the same format. X here, x there, right? Then we're gonna make this one will be series n equal to 0 to infinity, negative x to the third power to the n. So look, negative x to the third, negative x to the third, right? Okay. So this one just extend. When n equal to 0, then we get 1, right? When n equal to 1, we get the negative x to the third. When n equal to 2, we get plus x to the 6 and minus, yeah. Okay, now look. They give us that part is converges when x equal to absolute value is less than 1. So that's here, right? So this part, yeah, this part, I'm doing this one. This part is take the absolute value is less than 1 is converges, like a geometry series format, right? There is R, right? So we have negative x to the third power is less than 1, converges. Okay, now we take out the absolute value, then we get the x to the third power. Okay, -1 between there. So for x is between -1 and 1. So there is an interval of convergence. Okay, so we say that. Okay. So any question?